Okay, guys. Then today we start a new topic. Remember in the first section, 6.1, they were about translations. Okay, so I move one figure with all the points. I don't change the form of the figure. So I move it completely to other position. Okay, but it has the same measures and for the angles and the sides of the sides. Now for this one, for this part, we have reflections. When I have to move one figure using one reflection, it's like I'm going to project the same figure in the opposite side, okay? So the figure is going to change its orientation. The form is going to be the same, the measure for the angles and for the sides is going to be the same, but I need to change the orientation because it's like in one part you have one figure and the other part you have the other that you project, okay? So it's like they are going to see each other. If you close the one part of the axis with the other one, then I'm going to show you the example number 1 that appears on the book. Okay, so when you are going to graph something, guys, you need to be clear, okay? You need to be sure that you have the same distance. So you draw the line on the middle and you are going to project the figure in the other side, but it has to be in the same distance, okay? With the same size for all the lengths, okay? For all the sides, okay? Has to be the same length and the same measure for the angles, okay? The same form. The idea is only to project this in the other side, but the figure is going to be the same. Only that in the opposite orientation, only that. Then we are going to see the example 2. In the example 2, we need something more interesting, I think, than in the first one. And remember, to project that, you need to have an imaginary line, okay, in the middle, so we can have the same distance for both sides. Then, guys, we are going to draw the example number 2. You already see the example. You already saw the example on the book, so now we need to place all the points. For example, the first point that I have is the point A, and I have the coordinates for the point A. They are -5 for x and 2 for y, so -5 for x and 2 for y. The point is going to be located in here. Then the other point that I need to place is B. The coordinates for B is -5 for x, but it's going to be in 4 for y. So -5 for x and 4 for y. Later, what other point that I need to place is C. C is located in -4 and +5 for y. The other point where it's going to be located, D, is in -3, in here, -3 for x and 5 for y. So the same vertical distance. And the last point, that is E, is -3 and 2 for y. So this is the figure that we have. We are going to complete it using this part vector, okay? So A and B and C, we connect all the points. Remember, when you do this on your notebook, you need to use a ruler, okay? So we can see. The reflection is easier, guys, in this case, because if I move this, how are you going to project? You imagine that this is your line of reflection. The axis is going to be your line of reflection. So you need to keep both figures at the same distance. So even without looking at this, I can draw the figure. You are going to see. So for example, if I have the points, how many grids is separated from the axis? 1, 2. So I can do the same. 1, 2. And it's where is going to be located the point A? In here, right? In here, because it's this point. B is separated 2 units 1, 2. So this has to be prime, and B prime. C is located in here, right? This is going to be C prime. D is going to be located in here. And the last point is going to be located in here. So we only connect this. Even without doing anything, you only check that you have the same distance. 1 grid, 2 grids, and you project it, okay? This is the idea, only to project this figure, okay? So we start in here. And you can see it's the same figure, only the orientation is the same. But if you close it again, if you move this and you place it on the other one, you are going to see that the point D with the prime, D with the prime, C with C prime, okay, all the points B with B prime, E prime, and A prime, all the points are going to be one completely on the other one, okay? It's the same figure, so you need to keep it, okay, in that way. I told you before, sorry, because in here I don't assign the letters, okay? It assigns automatically for each point, so we cannot write A prime, B prime, something like that, but you need to remember about that and write it, okay, the points when you solve the exercises. Okay, so what else we have for this? Since the point A is 2 units above the x-axis, this is the point, okay? 2 units above the x-axis. The point A prime will be 2 units below. So I have the x-axis and I move below 2 units more. The corresponding side lengths and angle measures remain the same, but their positions and orientations are different, okay? So only the orientation and the position, because the position for this one is up and this is down the axis, okay? So the position, if you project it in here, for example, the position is going to change too. And the orientation has to be to the other side. So this part that is a oblique line is going to be or in here, for example, okay? So this is the idea that you reflect like this is a mirror, okay? That in one part you have an image and in the other one you have the opposite image looking each other, okay? Okay, something like that. Then I'm going to show you now the example number 3. In the example number 3, we need to describe the reflection. So they give you the figure at the beginning and we describe what is happening in here. So what is a rule that describes the reflection that maps parallelogram A, B, C, D onto parallelogram A prime, B prime, C prime, D prime. So I'm going to load again the space, the page, so we have the blank space to do all the points. So for the other part, what I need to place are all the points. So what are the coordinates for A? We need to guess because in here we don't have the name of the points, but we are looking at the grid, so I'm going to do it to represent it with you again. So for the point A, I have positive 3 for X and 3 for Y. 3 for X and 3 for Y is going to be located in here. The other point, B, is located in 6 for B and 0 for Y. So it has to be located in here, 6 for X and 0 for Y. C is -2, okay, is 4 for X and -2 for Y. 4 for X and -2 for Y. And the last point is located in 1 for X and 1 for Y. So this is the figure that we have. We only connected using this vector. A, B, C, D, and finishes in A. Okay, that's the parallelogram that I have. and later I only need to project the same to the other side. So guys, even if I don't know the points that I need to place, so you only move it to the other side, I project it to the other side. Where is going to be located A in the other point? If it's 3 and 3, negative 3 for X and positive 3 for Y, because it's going to be at the same distance, only that in the other side. And when you close it, it needs to fit. B is positive 6, so obviously in here is negative 6. C is 4, so it's going to be located in negative 4 for X. And D is 1 and 1, so negative 1 and negative 1. Okay. Positive 1, sorry, for Y, and negative 1 for X. Okay. So I only complete the figure. E, F, G, H, and H2, G. So this is the figure that I have. And it's projecting in what way, guys? It's projecting in the y-axis, okay? So again, like a book, if you have something in here and you close it, it's going to fit perfectly on the other side, okay? All the points. So this is A prime, B prime, C prime, and D prime, okay? So if you write the name for the figures, you need to remember about that, okay? So each point of the pre-image is the first one that we have, is the same distance from the line of reflection. The line of reflection, I need to imagine that is the y-axis. In this case, I'm reflecting in y. I'm reflecting using y-axis. The other one was in x, remember, because it was reflecting through the line for the x-axis, okay? This is for y. So then, each point is the same distance from the line of reflection as the corresponding point of image A prime, B prime, C prime, and D prime. Okay, something about that. In the other one, you have one example. You can see the example that says try it. This is reflected across the line x equal negative 2. So again, I'm going to charge this so we can eliminate. I'm going to draw a imaginary line, guys, because in here I don't know how to, I don't have a way to divide this segment, okay? But what you are going to do is like a imaginary something, okay? So the polygon ABCD is reflected across the line x equal negative 2. So for example, if you have one line in here, okay, imagine that is a line in here that is dividing. You are not going to draw the line every time. You can do it if you want, okay, if you need it in the moment, but you don't need always to divide like this, okay? The line of reflection, you don't need to do it every time. And we have one figure in here that is a B, C, D, E. So the pre-image is the one that I have in this side. And if I project it in the other side, it's only that I'm going to have the same separation, and the separation is only 1 unit, okay? The point A is located in 4, negative 4 for S, negative 4 for X, and 4 for Y. I think that is projected in here. The point B is 1 below, so I think that is this one. This is going to be C. C is negative 3 and positive 2 for Y. The other point D is going to be located 2 units in here, so negative 3, negative 5 for X and 1 for Y. And the last point that we have is this one, okay? So we only connect this figure. I think that this is what we have. So what we need to do, guys, only to project this in the other side. So even if I don't know this point is going to be this one, okay? This point is going to be this one. The other point that we have is going to be located in here, right? Because if you have -5, for example, okay, so you move the number of units depending on the line of reflection. So this, can you see, separated 1 unit. The other point has to be located in here. The other point is going to be located in here. This point is going to be, okay, not only 1 unit, but 2, okay? So that's what we have, right? I'm solving this exercise because maybe that this can confuse you in the first moment, but you can see that is going to be the same, exactly the same. You just project the things to the other side, but the important part in here, why I decided to show you this, is because they are projecting not using the axis, not using the x-axis or y-axis, x or y, sorry. Okay, they are projecting using the line x equal -2. So this is going to pass through the x equal -2, and you draw the line in your mind maybe, or you can draw it if you need it, okay? But the important is that you know how to project it correctly, okay? So this about this exercise. Then guys, I'm going to finish the recording in here, okay, about this topic.